right. How's it going, everybody? Welcome back to the Anarchus Project. So tonight, we're gonna continue working on the MIDI controller as before. There's still a lot of work to do on that, and we'll start getting into the actual like physical design, the mechanical assembly. So I think that'll be awesome. But first, I need to actually go through and do some other housekeeping stuff. I'm trying out some new stuff on the stream because part of this whole channel is people working together to make things, and I need to work towards that goal a little more rather than just continuing to uh, just make stuff at random. So that's what I'm gonna be working towards. So I'm gonna be working towards that goal a little bit tonight. And so what that means is I'm gonna be changing the layout of the stream a little bit and doing some other stuff as well as we'll shouldn't take that long, and we'll get into actually uh, working on the project. But I wanted to start with that first. So I'm gonna flip over to. I've started creating a new screen here, a new layout, which is basically everything kind of reversed around, and you can see it's not done yet. Everything's kind of messed up still, and so we need to start working on that first because this looks a little bit weird. So I'm gonna start with this, and any feedback on this on the layout as I work and everything would be greatly appreciated. I would love it if somebody would give me an idea, like if something looks good or not. Then, just for reference, I have one of my designs open over here, and this is the MIDI controller. So I'll keep the schematic open just so we have something to look at in reference to like what kind of stuff will be showing up. So yeah, let's get started. I'll turn the music back on. Let me know if it's too loud or too soft. And let's get started working here. So let's see. This needs to move. Honestly, that probably needs to go, actually. So I had a problem earlier where that is basically a duplicate of the other current goal up there, and there we go. So we don't want, and apparently if you modify one of the duplicates, it modifies both, and we need these to say different things, so I need to get rid of them. So just bear with me here. And we'll figure it out. Okay, let's see. I need to rename something here real quick. And I know this isn't going to be the most exciting thing ever, but I really need to get this done, and I think it's okay to delay actually working on the project to do this. Also, let me know how your Tuesday night's going, or Thursday. It's Thursday now, isn't it? Man. Let me know how your Thursday night's going. All right, let me rename this. All right, and then I need to change the size of this. There we go. All right, so that should be right about where the chat is. So if I put something in there, say hi if you stop by. Oh, I can't type today. There it is. It's a little small, but it at least showed up in the right spot, so that's good. I wonder if I can make the text bigger. Let's see, background color. Nope. It's not it. I'm looking at sliders here. I'm trying to figure out, oh, font settings. Here it is. All right, make it like 40. It's got to be way bigger to be readable. All right, test message. Ah, that works. Might be a little too big, but I think it'll work for now. I don't seem to be getting that much chat message right now, so I think having just this little box down here in the corner will be fine. Okay, now I need to add another background. There it is. Right. Probably a bit much, but I plan on putting it down here. I'm going to make it the same color as the chat background. I just need it to be longer. All right, let's see. Maybe 4,000? I think 4,010, 50. That works. Okay. And then the color of it needs to be the same as the other one. So let me look at that real quick. 141414FF. Let me just copy that. And then one four. Not quite what I want. Hang on. Oh, here we go. I can't see the the box that I'm typing in is so faint. I can't see it, but I think that's it. Okay, that got the right color there. Does it sound like the music's really loud to anyone else? It sounds like it's kind of loud to me. Maybe I just have my volume turned way up. Oh, I do. That's probably why. Let me know if the volume on the music is too loud or too soft. I can figure it out and make it better. Okay, so that's good. Okay, now I need another text source. Maybe the stream is just going to be me learning Streamlabs the whole time. Okay, then where is this? There it is. Well, that's not what you want. I probably had to put something in there. Yep, and now it is enormous. Well, let's just bring that down a little bit. All right, we'll get there. So now what I want to do with this, and this will lead into some of my, what I'm talking about doing to change like how this channel works and everything. How about make me laugh? But you got to keep it family friendly. I don't know if that conveys everything I needed to convey. So basically, the theory here is I've put together a bunch. I've bought a bunch of Dogecoin, and in exchange for people helping me, I'm going to offer them tips or bounties, basically, if they can help me with specific problems that I'm having. Because I noticed that sometimes I get stuck on problems for a long time, and it would be nice if somebody who knows a little bit about it would have some incentive to help me out. So the theory here is if I offer up bounties for specific things, and I might even offer up more than one at a given moment, but this is what I'm going to do right now. And just to test out this theory to see if it even works, if it even draws any attention. So we'll see what happens. It means I can't laugh for the entire stream, though, until somebody actually says something funny. All right, we'll start with that. We'll see if it garners attention and everything. I think that background needs to be a little bigger, actually. And let me adjust where this is all at. There. Maybe a little bit bigger. That's probably good. All right, we'll see if that works. All right, so this is the new layout I'm going to be working with. Let me go and lock everything into place. And even in Streamlabs, like on circuit software, you can lock things into place. So let's do that. I think everything looks good. This is a really... Let me test the message thing real quick. Man, I cannot spell. Okay, that did fine. Excellent. So we'll see how this works. So the idea with this whole channel is to pursue some sort of process of design and development where people can kind of jump in and help out with the little things that they're experts on, you know, and get rewarded for it, basically. So that's what I'm trying to do here. Also, the reason I flipped the sides, like flipped where the webcam was and everything, is because typically I'm looking at this screen, which on the old layout meant that I was kind of looking like, it made it look like I was looking off frame, like looking over here. Now I look, you know, off the edge of the screen over on this side. So now when I'm looking at the screen where I'm working, it's effectively, it almost looks like on camera that I'm kind of looking at it too. That kind of perspective is there. So hopefully that makes everything a little bit, seem a little cleaner. But yeah, all right, we'll see what happens. And then now I guess I just need to actually get to work. So our current goal of picking parts for the assembly and create the models is still valid. Ah, that needs to be over here. And then I need to, hey, our 3D model. It still looks so good. I really hope, I'm kind of tempted just to order it in the black. I still haven't looked up pricing on that yet. All right. All right, so I need to make a assembly bill of materials. So what I think a lot of tonight is going to be just trying to figure out what oh shoot. Here, let me pull something up real quick. I just realized I needed to close some things out without showing them on stream. I normally check that beforehand, but I guess I forgot to tonight. Let's see. All right, that looks good. All right, I think we're good. We can head back here. All right, let's go from there then. So, okay, so I made a new bill of materials specific to the assembly. I just copied the old one. So we're going to have to delete all the items in it and then okay, here we go. Okay. There's a few things we're going to need. Obviously, we need the enclosure. The circuit board itself. So we'll consider this circuit board like its own part. And then what else do we need? The enclosure circuit board, we need the USB-C port. We need a USB-C cable. Oh, actually a USB micro to USB-C cable. Because that's going to be for the interior. And actually, I think I laid out a whole diagram for this. Let me pull this up real quick. No, I don't want to install the new version yet. Okay. So here is our diagram. So we have port. Our PCBA includes a lot of this stuff already on it. But we didn't, the buttons are actually not directly attached to the circuit board. We did kind of change that. So we do need the buttons, which we already basically have. Let's go ahead and update our quantities. So I'll go back through and replace all this stuff with the proper thing. Or at least the links once I find them. Alright, so let's figure out here what else we need. We need buttons, we need screws. I think I'm going to put some rubber feet on the bottom. We need a label for the top. / stickers. Quantity 1 for now. There's actually quite a lot to this. Label, top enclosure, bottom enclosure, circuit cutouts, screws. We probably need offsets because we're probably going to have to raise the board up. So offsets for each of the screw locations. But we'll figure that out. As we do this, we'll realize things and have to learn new stuff. Okay. I think that's more or less everything for now. And then I'm going to go here into this. I have this other document open and find the link for the buttons because we already have that. Okay. The rest of that's not necessary. And then I do have the link for the case as well that we want to try and use. I could probably just move this in some actually so we can see that. Yep, all right. So there's the case. And actually, if you want to see it, here it is in all its glory. Pretty standard affair. What's the difference between these two? Oh, that's kind of cool. I didn't know that was an option. Might go with that one, actually. I'll have to think on that. The link is the same either way, so we might have to, let's go and put a note in here. Okay. That looks good. And then I'm going to search this online. So I have the link there to the main site. It'd be cool, though, if I could find it on, like, a distributor of some sort, like DigiKey or something. But it looks like it may not be. You can get a quote for your customization. I wonder if we can get them to cut it for us. It'd probably be really expensive if they only had to do like one or two. All right, we'll come back to that. So keep that one open. And all right, so we got to figure out what else we need here then. Our USB-C port has kind of confused me. We need like some sort of panel mount thing for that. I wonder if we can find something. There is some stuff that exists, but it's usually too big. Oh, this isn't bad. So something like this would be pretty good. You just need to get an adapter on the inside. But still, like $8 for one of them. That's kind of expensive. I guess that's pretty common, though, to have something pretty expensive like that. They have the exact same one for USB micro. right here, and it's only $250 each, whereas the USB-C is $844 each. So that's really expensive. How expensive are the polycase things? $5, not too bad. I'm trying to think like the cost overall as well, because we could very easily spend a lot of money if we're not careful. So if we pick one of these, if we pick this USB-C solution, we still have to have a converter inside, because what's on the Teensy is a micro. I wonder if that's a thing that exists. A USB micro to USB-C panel mount. I doubt it. I stand corrected. It does exist. It exists here on Adafruit. Look at that. So it's a micro on that end, which is what would plug into the Teensy here. Hopefully you can see it. Yeah, so there's the micro port on the end there. I know it's way too fuzzy to see, but it exists. So this would fit into that, and then on the panel side, you'd have this USB-C that would screw into the end. So we'd have to cut a little slot for it and then drill some holes for the mounting points. I do like that. It's just a matter of whether or not it will fit that well. Because the problem with, especially since it's a really short cable, it may there may be a lot of tension in there. But I think that could work. I wonder if they have this on like DigiKey or something. Micro panel mount. Or like Amazon, maybe? Gotta find a place for it. What is the part number here? 4056. 4056. I wonder if this will work. Is it in stock? It is in stock. Perfect. So we could buy a bunch of stuff from here. Okay. Let me just save this link. And I think this is what we'll use on the inside for our USB-C connector. And this will take care of the cable as well. So, where is it? Here it is. The port and the cable are now one thing. So I can delete this row. All right, excellent. Now we'll have to double check that everything fits and it's long enough in the assembly. But we have that for now. We already know where that is. So next we need screws. So the case will come with screws to hold it together, but we need screws to mount the circuit board in. So we're gonna need 4 of those. I wonder if we can get those from here as well. I wonder if DigiKey sells screws. Screws and bolts. You can also get them from like McMaster. That's where I tend to get them from. But if DigiKey has the right size, then I think we can live with it because it'll be easier to buy everything from one place. Oh, excuse me. Okay, so what size do I need? There's one that could come with. Oh, interesting. Okay, there's one that you can get with the cases. Like when you order the case, you can also order the screws for mounting with it, and that actually might be the. Well, actually, I don't know if that's the best option because we were talking about using standoffs and stuff. But the problem is a lot of screws are really expensive too if you just buy them by themselves. All right, well. Hmm. Let me double check then that we got our widths and everything correct here. Let's so it's giving me the example. Here we go. So I can go here and go to this view, and I just want to check these to make sure they're big enough. For view details. Well, we have models of them, so we can always use that too. I think we'll be okay. One 190 mils. 190 mils, so that's a little bigger than that. Oh, wow, that's right about the size of that. Interesting. Okay. Yeah, it looks like our size here will be okay. Might be a little too big, but that's fine. What are these? Adhesive PCB mounting standoffs. Oh, interesting. You can buy little adhesive standoffs here. Look, that fit inside the case. So you just drop them in there wherever you want to mount to. If you don't want to mount, like, all the way to the actual like mounting points, and then you can put something smaller in there. Good to know. All right, learning a lot. I know we're not accomplishing or moving very fast, like not moving very fast, not getting a lot done right now, but we are. I am learning a lot, which is good. Okay, so we got to figure out. We're not going to be able to pick everything out here until I start actually modeling and seeing how big this needs to be. but I think we can get close. Okay. I think there's a helicopter outside. So I'm thinking about using a 440. Here we go. In stock. Active. Apply all. You can get plastic ones. I think I'm going to prefer metal. Type features. Machine screw, panel shoulder, thumb screw. I want to get something that can go into plastic easily. I may have not picked a good option by picking 440 because that's typically a machine screw size. I should pick something based off a diameter that'll fit better into plastic. And somehow is not horrendously expensive. All right, let's go back. Thread size. I don't think I fully understand how these numbers work. I need something that's more like self-tapping or something. Plastic thread forming screw. Well. Oh, I should clear this one. 2 remaining. Does this just mean it's a screw made of plastic? No, it's just specifically 1. Okay. I think that's too small. But it'll have a drawing. Maybe it doesn't. Interesting. Alright, yeah, I don't think that's a good option. What's the difference between a panel screw and a machine screw? It looks like something that'd be a little better for plastic. Oh, it reaches way down. That appears to be interesting. Okay. So we can probably go back on that one. Yep, not the right thing. I have a lot of machine screws. Thing is, these would work. It'd just be annoying if you had to take them out later. I guess we could get away with it, though. And just pick one. So we're not here all day. All right, so we'll have to figure out like all of the dimensions here, like how deep the pocket is and how high the board's gonna have to sit and all that. But this at least gets us closer. So I'm gonna save this search into our document here. All right, we need like, else do we need on that list? Rubber feet, labels and stickers, and offsets, which we don't know totally what we need yet. See rubber pads, see bumpers, feet, grips. Hey, they do have stuff. Huh. They got all kinds of weird stuff. This is cool. How's all this stuff from? Go. Let's pick 3M. That would be adhesive stuff typically. Yeah, like stuff like this. All right, we can pick something from this list eventually. I really need to get this thing into like a 3D model. Like that's the primary goal here, because then we'll be able to start trying different things, different sizes, and see what size we actually need. All right, let's try it. Circuit maker. I'm gonna have to Google this. How to export step file, I guess. Okay, let me go project, demo file. It's an import option. Outputs. Lungs, pick and place, Gerber, C-drill, printing. We should probably honestly check that one just to make sure all our parts are going to line up. Step. There we go. Oh, it's got to commit some files. Hold on. All right, give me something. Thank you. Let me go put it in the project files. There we go. Components with 3D bodies. Export all. Generic 3D models. I think the default options will be good. Done. Okay. Let's see if that worked. I think it did. Hold on. Gotta open up some CAD software. It seems my bounty has not attracted anyone yet. That's okay. Didn't expect this to work the first time magically. I'll change my stream notification next time to include it, and hopefully that'll reach out to a few people. Okay, here we go. Free CAD, because I can't afford anything else. Then we will wonder what this is even going to look like, if it'll even get like colors right or anything. Interesting. I think that'll work. That's kind of cool. How do I move around in free category? That's right. Look. All right, we got our model. Oh, wow. Unlike the other, unlike Circuit Maker, we can actually flip around through common views with the buttons. Okay, so there's obviously not a whole lot on there, but it does give all the important bits, like where the holes are and whatnot. So it doesn't have all the stuff, because I think even in a step file, there's certain things that can't be drawn, like textures and things like that. So it does have all the parts on it too, though. That's cool. Can I turn them off? I can. That's well done, actually. I like that. All right, so how do I... Basically, I want to save this as an assembly, and I want to include more parts. So I guess next thing I need is a download of that case, which I don't know if I've gotten before. I don't think so. Hopefully it won't put up a fight. Oh, wow, they give a bunch of different options here. All right, well, let's just extract all. All right, let's just see what these are then. All right, we got a lot of assemblies now. Probably more than we want. Let's look. Where is there? That's the bottom. Okay, so that's the top. What's that? Green apart, make it adaptive. Interesting. Okay, so which one are we looking at? It's hard to tell. Unnamed 4. This one. So we can hide that, and then we can see inside it. I should look through all of these real quick, because that doesn't look right. Hold on. All right, let's flip all these up. All right, so bear with me, because we're going to be going through and deciding which of these is the actual part that I wanted. Yes, reset. Okay, so the part number changes. Oh, okay, so there's 4 different options based on if it has the mounting points and all that stuff in it. Yada, yada, yada. So this is the SL64P MBR. Okay, so that would be this top one right here. This should be the correct one. This one I'm looking at now. So if I hide this. Okay, yes. And it even comes with a PCB model. That's kind of funny. So we can take that out. Wait. Where are the mounting points? Are they on the other side? Am I looking at the wrong side? Oh, I'm looking at the wrong side. That's the bottom there. Hold on. Let's flip it around. Here we go. That's the top side. And then take that out. And there's our mounting points right there for our circuit board. Don't really like that the screws are on top like that, but I guess we can survive. Okay. Yeah, so check that out. That looks kind of cool. It's go figure out all of, oh, so I can turn off all the screws individually. I wish I'd known that PCB model existed. I would have tried to make one that would fit that. All right, and there's our top shell. And you can see the recessed portion here. All right, so what we need to do is somehow get our PCB like in this model in the same thing so that we can like slide them together and move them around and stuff. So, and I have no idea how to do that in FreeCAD. But let's just try some stuff and see what happens. All right. Now that I know which one of these is the correct one, all right, let me just go ahead and close all this. Discard. 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 All right. It's going to be a lot of me Googling FreeCAD stuff tonight. Let's see. You create group. What does that mean? File import. All right, that kind of worked. Oh, hey, okay, they are in the same thing now. They're wrong orientations, but they're closer. So we're getting somewhere. This is good. So I'm hoping that most of our work cannot be like actually like modeling things, because we can just import files for all the screws and standoffs and everything and show that it will all fit together before we actually do it. And I'm hoping to get a lot better with FreeCAD too. I wish I could like afford SolidWorks or something, but we need a lot more supporters on this channel for that to happen. We'll get there one day though. All right, so FreeCAD, rotate part. All right, let's see. Select the objects that you wish to move or copy. Okay. Press the draft rotate button. Where would that be? Probably need to open a toolbar. Here we go. Hope I'm still on the right thing. I can't tell. If this one's bolded, it looks like it's the active, and I don't want it to be the active. I want the PCB to be the active. Maybe not. Maybe I do want this one. All right, let's just see what happens. Whoops. Close. How do I do this? All right. Bonus points if anybody can help me figure this out. Oh, shoot. Okay. Clicked this. Oh, wow. All right. I wonder if I'll have to rotate them all and move them around. That's okay. So it would make more sense to rotate the PCB in this scenario then. All right. It's rotating on that one plane. Oh, and it's only rotating. Dang it. All right, this is going to be really hard. I'm going to figure out how to do this, though. Because all of these are like their own assembly. And, oh, yeah, the PCB would be way worse, actually. Yeah, maybe we do just want to rotate this assembly. Increment. How about 90? Did that do what I wanted it to? Okay, we're getting there. Okay, so that slides it up and down, and this is a rotate. So I need this one, just like that. And slide that over, slide it up. We're getting closer. Okay. This is going to be so much work to get it to, like, be correct. All right, getting there. Okay. Obviously, that's not centered, but we'll get back to that. I want to see, take the top off here. We need to hide the PCB. In fact, we need to delete the PCB. There's no reason for that to be part of this. All right. And then we need to transform this over. Okay, I'm going to need a smaller increment. That looks right. Slide it up. Oh, so close. Okay. It looks like we got our hole spacing lined up good. I just can't get it centered. I wish I could type in a translation, right? But at least we're closer. Okay. Add transform assembly. The standard transform is what it's called. All right, doesn't look like there's an easy way to do this. Let's just make this 0.05. Oh, wow. All right. That looks good. Okay. Oh, and then I didn't even think about the fact that it's not, like, flat on the... Oh, that's going to be really hard to see, too. well, you can see from where the screws are too, the switches do stick out, but I don't know if they stick out far enough. It looks like we are going to have to use standoffs and raise the board up a bunch. Okay. That's all right. We can do this though. I'm starting to feel like we're getting somewhere. I wish I could have like a cutaway so I could actually like see like what's going on inside here. Right? Because like there's still so much room in there. Yeah, not enjoying that much. Is there like some sort of view thing? There's got to be a tool. I remember there in another version of this I was using, there was a tool up here that I could like click on certain faces. I have to figure that out. Okay. It seems not quite centered now too. Oh, maybe it is. Yeah, it is. Okay. Oh, why is this grid still here? All right, so I've lowered that way down in. It's still not as low as it could go, but then if I add this piece here, you can see that the switches are barely sticking through the top part here, which means that we're going to have to definitely use standoffs to raise it up higher. So, to be expected, but annoying nonetheless. And I think I just realized something. Oh, yeah. We wanted this to actually be on the bottom here. So we're going to have to move this part. Yep, because we're going to want the buttons up here. All right, and then from the side, let's see. It's really hard to tell how high it is. I wish there was a way I could like do this with numbers or something, not just sliding it, but like type in a properties thing. But there just isn't, or I'm just not smart enough to Google how there is. Okay, let's start with that. Turn on this top piece. That's too high. Everything's coming through the board. All right. So we'll move this down some. It's too low now because I have no idea. I'm gonna have to get models of those like switches that are going on top too. I should probably include that. All right, modeling wise, there's a lot to do here. But I wonder if we couldn't go ahead and order the circuit board because we know that like that's most likely going to be okay. That might not be a bad option at some point if we get stuck. Yeah, that might not be a bad option. But in the meantime, we should try and figure out how exactly everything's going to fit in here. Man, I wish there was an easy way to transform this stuff. Actually, you know what? Placement, axis, position. I bet I could change it with this. Yep, I could. Yep, that'll do it. The increment kind of sucks. I can change that though. All right. So I should probably just go ahead and move everything to where it needs to be. All right, we're getting there. We're getting there. I'm learning a lot, and it is as we go. No, I say that a lot, but there's a lot to learn. This is, I think I said before, that this is the part that I am the worst at in terms of just like having done it before and everything. Like the actual physical design and CAD programs, I've done such a tiny amount of it that I really just don't know what I'm doing, and so I'm just gonna be learning the whole time. But learning new skills is awesome, and it'll help me out in other areas too when we encounter this stuff in the future. And whoever my one viewer is, I really appreciate you sticking around. Sorry. Look at something real quick. All right. Well, I guess I'm gonna start lining these things. Actually, you know what? I'm gonna figure out how to turn on the. There's a view thing that I should be able to turn on. The navigation cube. That's what I want. So how do I turn it on? It doesn't give me anything. I'm gonna figure this out though. You just wait. We got this. Oh, it does have a Python console for this. We could do a lot of this by Python probably. That's cool. Yeah, these are all just standard views and things. That's the one we want. All right, let's see. Man, nobody will tell me how to turn it on. Mouse navigation. All right, well, I'm going to figure this out then. Tools, edit parameters. Here we go. Preferences. And then what are we going to? There's a thing called Navicube. It doesn't look like it's here. Do I not have it installed? That's kind of odd. Would explain why it's not showing up. All right, I don't know then. I guess we don't get access to that one easily. Just have to do standard view toggling. Shift left, shift right to rotate. Okay, that'll work. All right, so first things first. So what I'm going to do now is actually move some of the stuff around. So I want the enclosure to be at 0, 0, 0. Basically at the origin. There we go, it's in the center. And then circuit board, same thing, just to start. And the Z is what's coming right at us, I believe. Oh, excuse me. Yep. So putting it at 0 on the Z puts it right on this edge right here. So you can see how the enclosure was kind of designed around that origin point right in the middle. Oops. So if we go here, we can also see that our part, the origin point is right on this bottom corner, but for the enclosure, it's right in the middle. So they're a little offset that way, but that's fine. So we need to figure out how far down and how far over to move it. And that means looking at a lot of different things to figure out the distances. So cool. We need to look at different drawings and different things, and we'll get there. And I was worried it wasn't gonna be boring tonight because I don't know what I'm doing. Oh, what? No. When did that start happening? I tried to open a PDF and it decided I wanted to open it in Microsoft Edge, which is really not something I want to do. Okay. So this is the drawing here that I'm looking at. So we need to, using these measurements, get everything to line up. Right. Okay, unfortunately, I need to figure out how to change our units here. Because everything has been done in mils, just because that's what the drawings were in. Even though I prefer metric. Preferences. General. Oh, there's a units tab. Okay, got it. Okay. So inches are there and inches are there. Okay, that's good. Then we know that the circuit board is 0.28. Oh, no, wait, 0.14. Yeah, the holes are 0.1. The center of the hole is 0.14 inches from the bottom of the board. So we need to add 0.14 to the translation down. So it looks like we're going to break out the calculator again. All right, so the difference between the standoffs is 4.760. Divide that by 2. That's how far down we got to go, but we have to add 0.14. 2.52 down. And what axis is what? That's on the Y. So on this particular part, on the Y, negative 2.52. There we go. Perfect. And you can see that it's shifted down to line up with those holes. And now we need to move it over. And I need to go back to Circuit Maker here because I don't remember how far over that hole was. 142.5 mils. So we need to add that to however much we move it. And that would be our X. So it's 2.755 apart. Divide that by 2. We need to go over that much, but we need to add whatever number I just looked up and forgot. 142.5. So 143.8875. 143.8775. So minus. Oh, that's in mils, isn't it? Oh no, I messed that up. Hold on. I just realized looking at that number that that was an absurd number. 2.775 divided by 2 plus 0.1425. So 1.53. And that is the theoretical correct position, even though it looks kind of wrong. Why does it look kind of wrong? Is it just the... No, it actually is kind of wrong. Interesting. So we need to figure that part out. Why does it seem off? I think because it's off on both, it does mean like it exported wrong. So I think our measurement just has to be wrong there. Let me do the math again. Oh, I did do the math wrong. I was using the wrong constant value to start with. Should be 1.52, not 1.53. Obviously. Yep. There it is. Okay. All right, let me save this. All right, there we go. All right, making good progress. I guess now we need to figure out how high it needs to be to look good with the, or to give enough room off the top shell. And I guess that is entirely going to depend on, oh shoot, I didn't even think about it. We need the slider knobs as well. We need 3 of those. I'm hoping I can find some on like Amazon. Here we go. Oh man, it's really hard to guess how tall they need to be. It'd be cool if I get like a model of them as well. Oh, there's a ton of these here on Amazon though. A lot of different types. That's cool. I wish I could get a drawing of these parts. So I'm just looking up these knobs online and figuring out slider fader knob. Interesting. I might have to just make the model myself because it doesn't look like anywhere that I'm looking I can find it easily. All right, that's okay. Four by 1.2, which I think is right. Let me look up the, sorry. I need to look up the actual slide potentiometer so I can get the drawing again. Okay. So which one of these did I get? I think 15, and I got the CP, so the metal lever. Refer to the drawing. Wait, this doesn't look right. P, metal lever, refer to drawing. Huh. It may not actually be as tall as I thought it was. I'll have to check that out. But the problem is I don't know how far on like the knobs push onto the slider, so I don't know how high above the thing I need to get them. So I don't want it to be too high, or it's just gonna be like they're gonna be way up, or if it's too low, then they're gonna be grinding on it. So I need to figure that out. I wonder if maybe I should just go ahead and order some and then go from there. But we can toy with it tonight. I want it to be like, I don't know, probably at least 5 millimeters up. Interesting. These don't actually seem to match up to this, or this drawing is not drawn to scale very well or something. I guess that happens. Well, that's okay. If you're curious what I'm looking at, it's this document with these measurements on it. I wonder if the height includes this. Oh, I bet it probably does. So it's probably 15 millimeters like off the board. Is there a way I can check that? I probably drew it that way, right? What is, let's see here. This height from here to here. .253 inches. That's like just over a centimeter, right? So just over 10 millimeters. Maybe it's not. All right, and then this. This is gonna be hard to do. It's hard to see this little spot right there. Yep. That 0.335 inches. Oh no, wait. I think this is gonna work. Hold on. I'm doing my math weird. But 0.253 plus 0.335. 0.588. 0.588 inches to millimeters. It's 14.9, so 15 total from the board. Yeah, it comes out to roughly 15 millimeters in total, but it's from this PCB. So this whole distance from the top here down. That actually makes a lot more sense now. I can delete these measurements. All right. So I think that makes it a little easier to decide how far below the top of the case it needs to be then. I'm thinking they need to pop out by about 5 millimeters. So that means from the top of the shell, it needs to go down 10. All right, there's going to be more math and drawing here. Hang in there. Here we go. So here, you can see that this is the top shell. And yeah, that's the distance there. Although I wonder if, hold on. No, we need to be careful here. Is the wall thickness different on the recessed one? I don't think it is. I think it's just ground in a little bit. Yeah, it looks like it is. .110. Okay, there's going to be a lot of math here to get this one right. No way we're finishing it all tonight, but that's okay. So looking at this whole distance here, this is just me double checking some things. 1.140 minus 0.924 leaves 0.216. And then if I look down here, I know the thickness of this bottom one is 0.106. So I subtract that, and I get 0.11, which is the thickness of this top one right here. So I am reading that correctly. So now we need to figure out how far to raise up the PCB. And honestly, we know that the center line is at the 0 point, so that might make this a little easier, actually. So this distance, 0.385. So if we raise it up 0.385, then the PCB should literally be flush with the top of it. We can try that, actually. So let's include the top shell here. And then move this up 0.385 inches. And I think that did it. Yep, that made it flush. If I can kind of rotate it around so you can see, but yeah, it's right on the edge right there. That's perfect. Or not perfect, but it means that we are reading all this stuff correctly, so that's good. All right, so is there a way I could like lock this stuff? I guess I can't. That's unfortunate. I wish I could like lock them in place. All right. And then move this up this way a little bit. All right. So we need to slide this down basically. So if we go down by 0.03, then it should be flush with the inner piece here. So what is our current value? So we go to 5.5. Then that should be flush right there. I think it is. It's really close, but I think it's correct. All right. So then, in order to have 5 millimeters above, I need to go down by 10 millimeters from this point. What's 10 millimeters in inches? So that 2 inches. I don't actually know what it is. 0.393701. We'll go down 0.393. So 0.355 minus 0.393, and that'll leave it a little higher just for error. So 0.355, hold on, minus 0.393, so negative 0.038. Negative 0.038. And that, supposedly, is the ideal placement for it to stick up just high enough to have the switches really close to it, like low profile, but still there. Man, it's nice to often, if you can get a lot of screws and like standoffs and things, a lot of different sizes, then you can just try this out and see what works best. Doing it this way is kind of annoying, but not bad. All right, so if I turn off this top piece, we can see where it is. And then somehow we have to figure out how big of a standoff we need, which I guess we can do just from some math as well. But at least we are getting there. Yeah, we're getting there. For the ones on this side, for these ones, there was two options. We could either drill out the bottom and mount them, which I wasn't a huge fan of, but it's doable. Or I was thinking maybe we could put standoffs on top and bottom and like maybe some rubber tips or something and kind of like put it on there in such a way that when you put the case together, it like holds it into place. I thought that would be kind of cool. So that's an option too. But all right, so we think we got that in the right place now. Oh man, we got to get the button models in here too. I guess maybe that should be the next part. Let's see if I can find them. I didn't even think about that. We might have to make models for those. I think they were just like Adafruit buttons, which means they probably don't have good models somewhere. E-switch. Oh, they're made by a company called E-switch. Okay. Maybe I can find them online to find the part. Because sometimes they'll just let you download CAD from their websites. What's the part number? No results for that part number. I find that hard to believe. Push button. Yeah, it's a push button. Maybe they discontinued it. I got the last ones. That would be really funny. Not looking good. I scrolled through this whole list of stuff. And I didn't get anything. So that means it may not be an active product anymore, which is really a shame because I thought it was when I bought it, but that's funny. The red one still exists, but then not the black one. Interesting. Okay. Well, that gets me a drawing of it at least, and then maybe I can request the 3D model for it. Yeah, I'm going to have to. So I don't have to make it myself. All right, I'll do that later. Man, all the little hoops you got to jump through for this stuff. I gotta figure out the distance of some things. I think this is actually going to be really close to bottoming out in our case. I didn't think about that. 7 is 11.2. 34 minus 11.2. It's 22.8. 8 millimeters to inches is 0.897 inches. Where's that drawing? Here it is. What's the distance inside? 0.897 inches. 0.924. Okay, so that will fit. Just barely, but it will. Good to know. Okay. So what to do next then? Because I got to request that CAD model. Hmm. I know I'm just trying to decide what to do next. I think we're making really good progress here, and it's looking awesome. I guess we really do need to figure out what standoffs we need to use, height there, and then get the buttons in the right place. And then we need to decide, and then from there we can start marking our cuts for the other parts. And then maybe I could go ahead and order some of the sliders, and I'll request the model for those buttons as well, and that'll get us all the parts we need to start kind of figuring this out. And then I honestly need to get the circuit boards on order soon too, because those might take a little while, and the assemblies could take a little while if we get them custom cut. So yeah. All right, I'll probably slow down and stop here tonight. I might try and commit all this stuff to the GitHub as well, so that we can see, so that it's there for everyone to look at. But no one claimed this bounty. I noticed that. So, all right. Well, that was fun. Learned a lot. I don't. I learned at least some stuff here is wasn't as hard as I thought it was going to be. So that's good. But there's still a lot of work to be done, and actually, honestly, we're getting close. But there is still some work to be done. Oh, we gotta cut a hole too in this thing for the USB-C. That's gonna be a little weird too. I'll have to figure that out. I'll have to toy around with the place we're buying these things from, because they can custom cut these, but I don't know if they'll do it for a small quantity of like 2 of these items. They may only do it for if you're buying like thousands. So we'll have to see. And it may be really expensive. Yeah, I'll think on that. But anyways, so this bounty thing, I'm gonna start trying to do more. Uh, if so down here, obviously, so I'm gonna start trying to use that more to help me out with certain things. Hopefully that'll attract people to help as well. And what I'll do is basically, if somebody can solve that specific problem in a way that actually works for me, then they will claim it and they can get it. They'll have to provide me with a wallet address, and I can send them the coins, basically. So yeah, but that would be cool. All right. Well, thank you all for joining me tonight. Thank you for being patient, and I look forward to working on this some more next week. Hopefully we can start figuring out all this assembly stuff, picking out standoffs and screws and all the other parts, and start marking where the holes got to be and where all the slots need to be, and we'll be good to go. We're getting close to being done on this project, so we also need to think about the next one. So I need another project, which is not something I was prepared to think about yet. So we'll figure that out. All right. You all have a good night. Bye.